All right, anyway, you all know who I am, so screw it. Next slide. So yeah, I got really interested in routers a couple years ago. Honestly, I didn't really care about the Wi-Fi part to start with, but see that little silver critter on the right? That's the homebrew router that I built running vanilla Ubuntu. And the whole reason that I did that is because I've been getting increasingly paranoid because I actually got my ass handed to me 4 or 5 years ago. A Romanian dude, at my best guess, just completely rolled me up like a rug, followed me from one machine to the next, to the next, to the next, and that was never going to happen again in my career, so I've been a lot more careful. And it got to really bugging me, that I've never really liked Wi-Fi routers. I always preferred to run, what I consider a real router, a wired only one, and just run, a Wi-Fi access point behind it. But the problem is that all the small business and home stuff that was without Wi-Fi had turned into like, this is our bargain basement garbage that we're throwing out that was, built from 15 years ago, and frequently couldn't handle more than like 10 megabits throughput. Just wasn't cutting it anymore. So I'm like, all right. And I didn't really like going the Wi-Fi router route because the radios tend to burn out in them, they tend to die earlier, and more importantly, back to the paranoia, you might go 3 years without updating the firmware more than anything. You have to keep up on top of it and like keep logging into it. You can figure out if there was a firmware upgrade available, and the manufacturers are not really too quick with patching that. So I was like, this isn't going to cut it. I want the same level of service in QA on my router that I have on my servers. I want updates pushed out to me of, within hours when they go 0 day, and I want them applied automatically. So that means I'm going to build my own in Ubuntu. And I did that, and I wrote a series of articles about it for Ars Technica. And the cool thing that I found out was that, I figured it would perform well because, we're going from, either MIPS or ARM-based stuff. The little Linksys and the Buffalo you see down there have MIPS CPUs in them, which are pretty much garbage. The big face hugger looking thing in the back is your Nighthawk X6. That's actually got a pretty solid CPU in it, given that it's a consumer router. It's got a 1.7 gigahertz, I think, ARM A9, so pretty much smartphone grade. And it does one hell of a lot better, but it did not hang even close to the little Celeron in that homebrew box, which ended up being the focus for the first article I wrote. Next slide. So yeah, I basically already said everything on this slide, but everybody, getting back to the Wi-Fi part of it, you look at these boxes and they say like these crazy things like up to 5 gigabits throughput, blah blah blah, talking about the Wi-Fi, and it's a load of bullshit. It's such a load of bullshit. It took me like 7,000 words just to unpack it all in one article of Ars Technica describing, okay, well, they're starting out with the PHY layer, and then they're adding maximal compression, when in reality, most of the data you're passing through is going to be already compressed, gzip, compressed web pages, all that. And then they're just adding like every stream on every single radio in the device together, adding it all together into one great big number, and that's how they get this like 5 gigabits. Well, in reality, any single device is going to be really lucky to get a couple hundred megabits out of it, even if it's like 15 feet away with a clear line of sight and nothing else talking. So yeah, stuff written in the box is crap. Next. That being one of the examples I was talking about, that's a D-Link. I forget the model number. Obviously, the marketing department, just like nobody was babysitting those guys, and that's the result. You got this crazy fire engine red looking thing, and they're claiming up to 5.3 gigabits. No, not so much. Next. So I got started. I had to become interested in the Wi-Fi part of it because the Wirecutter contracted me to start writing articles about mesh networking, which is fairly new at the time, where you get a router and a couple of satellites, and they're all supposed to work together to get Wi-Fi further out into your home and at higher speeds than what you can manage with just one router. And I started testing that stuff to figure out, was mesh even worth it at all, or was it complete snake oil like the Wi-Fi extenders that came before it? It actually did turn out pretty decent. But the question was, how was I going to test it? And the typical way is you just run iPerf from a laptop across it and say, okay, it does X megabits and it's awesome or it's not awesome, and that's it. But I don't really like that approach because there's a lot of things, there's a lot of components in the router that you're just not stressing with something like iPerf. iPerf is really good for stressing, the layer one, the physical layer. Is there a problem in your cable, or is there a problem just literally in the RF strength, or whether you've got multipath issues or whatever? But just for instance, we talked about the routers, the cheaper ones had the MIPS CPUs, and the more expensive ones had ARM CPUs. Well, that's not a whole lot of processing power. And once you start doing real network workloads, like browsing the internet, or God forbid, running something like BitTorrent, you can really stress the CPU, and what initially looks like, oh, well, this is, gigabit, when I just run iPerf across it, all of a sudden, you're seeing like a megabit of throughput or less. So, how is that actually going to test this thing? Next. The quote professional unquote way to do it is a piece of software called iXChariot, and that's actually part of the web page you get if you go to try to find a copy of iXChariot and purchase or download it. Literally, like, there's no prices listed, there's no download link. It's literally fill in your information for a sales hold contact. And that's just not how I roll. I don't like the fact that nobody else would be able to repeat my results and test things for themselves. I really want to advance the state of knowledge and have other people be able to check the same results and add to it. And also, in theory, the way this actually works is big OEMs like Netgear or D-Link or whoever, they'll spend $10,000 for an actual iXChariot license. But reviewers, like myself with magazines, you'll call in and you get connected with the right person, and they just go ahead and gift you a copy to use in the magazines. But again, I don't really roll that way. I don't like that. So I decided to just roll my own. Next. So, like I said, also the other thing is that iXChariot is still highly artificial. The nice thing about iXChariot is you can do everything that you could possibly conceive of with it. You can emulate just about any type of workload. It's very, very configurable, whether you want, one client or 5 clients, whether you want to do CIFS or HTTP or, DNS or whatever. There's a module in iXChariot for it. But again, you're emulating this, yada, yada, yada. So starting out for the mesh stuff, I decided I wanted to do Samba. And the reason for that was because in my experience, when people were complaining about speed in Wi-Fi as opposed to being able to get a connection, frequently what they were trying to do is access a local file server. Because the time I started writing these articles, most of the people I knew had 50 megabits or less. So usually their Wi-Fi could outperform their internet connection. But once you start saying, oh, well, I want to access my file server, or worse yet, I've got 2 laptops, I want to map and drive from this wireless laptop to that wireless laptop, then you start really seeing the pain. So I said, well, I want to get results in megabytes per second, like what you see, in Explorer when you're dragging files around and doing whatever, because I feel like that's where the pain point really is. Next. But then eventually I moved beyond that and I started using Apache instead, because after starting out doing testing that way, I got a lot of pushback, and I found out that a lot fewer people are as A, nerdy, or B, businessy as I thought they were. And most of the unwashed masses out there, they're really not doing much local anymore. The vast majority of what they're doing is web-based and HTTP-based, and they really are looking for results in megabits. God help them. Next. So my first thought was, well, this is cool. I don't even hardly have to write anything. I'll just use Apache Bench. Apache Bench is a tool built into the Apache Util suite, and you can have it do multiple concurrent connections. You can tell it how long you want it to run and have it grab a file. The problem is you can't really model a real network with Apache Bench because it has no rate limiting ability built into it. All it does is fetch stuff as fast as it humanly possibly can, and you can't really manipulate it to do much of anything else. At this point, what I really want to do when I moved to this multiple client testing, I wanted to, I literally wanted to model an actual small home network. I wanted to have one laptop in one room that was doing an unthrottled HTTP download. I wanted another one in another room that was simulating a web browsing session, another one in another room doing a voice over IP call, and then finally one by my TV doing what looked very much like a 4K video stream. And I just couldn't do that with Apache Bench because all Apache Bench will do is go balls out as fast as it possibly can. Next. So yeah, I kind of described that already. This is really what I wanted to move toward. I wanted to be able to do all of these things at once on 4 different devices in 4 different rooms, testing the same router to be able to say, and I wanted to actually measure the quality of those services in ways that were appropriate. The 4K video stream, I wanted to throttle that. I wanted to rate limit it, really is a better way to say it, to 30 megabits, but know that it really needed about 20 megabits to be able to deliver that stream. So as long as I can get at least 20 megabits on that client, I'm happy. I got a green light. My service is good. The voice over IP, very, very little actual data. My model of it was 64K chunks, rate limited overall to 1 megabit. So every once in a while, it will grab one 64K chunk, and then it will just sleep for quite a while before it grabs the next one. So that the overall workload only consumes megabit bandwidth. But for that, I'm extremely latency sensitive. I want to see results of 150 milliseconds or better on the VoIP call. The downloading, of course, is just an unthrottled download. And it's kind of arbitrary, but I said I want to see at least 40 megabits on that. If I see less than 40 megabits on my straight download, I'm going to be unhappy. And then finally, for the web browsing, that's the most complicated workload. And for that one, the way I set it up is I grab 10 parallel fetches of 128K file. And I measure my latency on that one from the moment I send out all 10 requests to the moment the last of the 10 requests comes home. And that latency is what I'm really concerned about there. I also rate limit that one to only 1 megabit. So it's not fetching these pages all that often. It's doing it, once every few seconds to achieve that 1 megabit throughput, assuming you've got vaguely decent bandwidth available on your Wi-Fi. But again, I'm looking more at the latency on that. I want to see latency ideally of 750 milliseconds or less. Once you add more than 3/4 of a second to a web page load, I feel like 1.2, just 128K, so yeah, 1.2 megabytes. That's about right for a modern, fairly heavy web page. You're putting together a bunch of resources for a meg or two worth of data, and if people have to wait more than a couple of seconds for a page to load, they're getting irritated. So I figure no more than 750 milliseconds of that ought to come from the Wi-Fi, and that's how we measure all those things. Next slide, please. So my next challenge was I need to actually orchestrate this so I can sit at one laptop and fire off all these jobs in parallel amongst all the laptops scattered throughout my house so that they'll really scientifically do the whole thing at once. And rather than just like some kind of cake, I decided to build a tool for it. I called it NetHydra. And you can feed it a config file where you can actually really predictably repeat an experiment and define, okay, well, these are my workloads. These are the clients that are going to run it. This is how I reach them. And then from the command line, you can just say NetHydra C config file and T for name of the test, and have it fire them all up on all your laptops. Next. And then the actual tool that I'm running with NetHydra, I ended up, again, I had thought originally I'd just be able to use Apache Bench, but Apache Bench ended up not being suitable, so I had to write my own again, NetBurn. NetBurn is very similar to Apache Bench. The biggest thing that's different is the reporting on it is different. It's a little bit more detailed for the kinds of things that I want. It will show me maximum latency, mean latency, 99th percentile, 95th, 90th, 75th, median and minimum latency for a particular test, as well as the overall throughput. I can set a rate limit, and again, the rate limit, the individual chunks that it grabs, everything with NetBurn is HTTP based. It will always grab a file at full rate the network connection is capable of, but if you put a rate limit on the workload, it will sleep in between fetches the exact right amount to give you the amount of throughput that you're looking for on the entire workload. And you can output to the console, or you can specify a CSV file to dump it to, which of course is what I do. It'll give you a nice big chunk of data that you can just import straight into a spreadsheet and work with. Next. So that's an example of NetBurn running right there. We're fetching a 128K file, rate limited to 10 megabits, and by default our time is 30 seconds, and that's exactly what it does right there. Obviously we didn't specify an output file, so we're not getting CSV output, but you can see all the data that it reports right there. Time elapsed, how many pages you fetched, how much data that added to, mean length fetched, page length maximum deviation, which is a really handy one, because if you're fetching a static file, you shouldn't have any deviation. But if you have any network problems and you get like 404 or a 5XX or something like that, you're going to have some teeny tinies in there, and you'll see some page length deviation, and that will warn you something was wrong with the network. You can't really trust these results. Finally, get your throughput, and then your mean latency, and then you get your breakdown from maximum to minimum latency through those percentiles. Next. So the other thing is, I thought, well, you know, I'll have to build NetHydra to schedule these things. And I thought, well, I'll run Apache Bench to actually do testing. And I found out, well, Apache Bench won't actually let me do everything I need to do, so I need to run that tool. But once I'm done with that, all NetHydra is really going to do is schedule jobs on these laptops using the AT scheduler. That's what it's for, doing, you know, one-time scheduling, right? Well, what's the problem with that? Your most granular scheduling with AT is 5 minutes, and so that wasn't going to cut it. I wanted to get the very worst nanosecond simultaneously on launching these jobs. I mean, maybe I could tolerate a second if I had to, but I damn sure wasn't okay with like, well, we'll start sometime in the next 5 minutes. So I had to build my own tool for the local scheduling as well. I had available a really nice name for that. I couldn't find anybody else to use, so we just did when it's time, run the command. It's pretty self-explanatory. Winits has much better scheduling granularity. You can only actually schedule to within 1 second on Winits. However, it's accurate to the several microsecond range. So basically, you can just go ahead and make sure. Part of what NetHydra does is make sure that the clocks are synchronized on all those machines. And so assuming your clock times are all synchronized, you'll have all your jobs fire off to within less than a nanosecond point. And that's actually useful for more than just this network testing. If you ever need to just run a command at a given time, you can use Winits to do that. It's a little bit less arcane than AT. So I've actually ended up using that in just various sysadmin roles for a few things since I developed it. Next. We've already seen that. We know what we're doing. Next. So yeah, one of the things that I really wanted to demonstrate, I had kind of a goal in mind when I started this multiple client testing. I already knew that, you know, one of your worst enemies in most home users' Wi-Fi networks is they just try to do too damn much, and they try to do it all on one radio typically. And so you would end up with, you know, you got a kid in a bedroom running BitTorrent, and you got another kid in another bedroom playing games. You've got, you know, somebody out in the living room wanting to stream video on a Roku. Somebody else wanting to browse the web. Everybody complains, well, the Wi-Fi is so damn slow. I've got all this signal, but it just sucks. And then try to go buy a router to fix it, and find a router and fix it. You know, you're utilizing all your airtime. So what I really wanted to demonstrate was how much wireless congestion hurt performance, and also the value of actually using multiple bands and trying to segregate the workloads so they weren't all contending with one another. In particular, I wanted to highlight how valuable band steering was. So I'd seen all the mesh kits out there pretty much would do really pretty intelligent ingress band steering to try to utilize all the spectrum available and minimize congestion. And some of the feedback that I had gotten from readers was that nobody wants to have 2 or 3 different network names, like, you know, my network and my network 2.4 and my network, you know, 5.1. They don't want to do that. They want to just have one network name. They want shit to just work. So that means you're going to need band steering. It's going to need to be pretty decent. Next. So before we really got started with multiple client network testing, I did some you know, single client testing, and you can see that there. We're downloading 16 meg files sequentially as fast as we can, and 1 meg file sequentially as fast as we can. And that browsing workload that I mentioned with the 10 parallel fetches of 128K files, doing that as fast as you can, but, you know, waiting in between all 10 fetches to come back before you start the next. And as you can see, pretty much all those routers, I mean, other than Plume there kind of sucking hind tit, they all look pretty interchangeable. They're fastest downloading the big file. They're not as fast as the 1 meg, and there's a big performance dip doing the browsing workload. No big surprises there. But it doesn't look like there's any real big winners either. Next slide. And you get basically, you know, the same thing. You start looking at long range. You start to see a little bit more differentiation because this is a download heavy test. So your uploads are going to be pretty bad with a mobile device or a laptop at long range, no matter what your router is, because you're still stuck with, you know, the transmit power on your mobile device. But a more powerful router with more transmit strength can give you a good bit better download speed at longer range. We're demonstrating that here, but still, whatever, no big surprises. Next. So this is where it starts getting interesting. This is the multiple client testing, and this is the format that I started out with. I don't know if it's the format that's actually going to publish, because the Wirecutter got real confused about it. It's not what they think of as graph. But what we're looking at here are the 4K stream, download, browsing, and VoIP call returns for each one of these routers. And we can see them, measure the things that we care about: the throughput for 4K stream, the download, and the latency across the board in each percentile for browsing and VoIP call. And the browsing is really kind of, that's your canary in the coal mine. It's usually the thing that goes worst the quickest, because you kind of need a combination of good throughput and low latency. And that's also the thing that most users are going to notice the fastest is, browsing my web pages or, using the interface in YouTube. Things take too long, it's pissing me off. Now, we're in what I call easy mode here. In easy mode, all these devices have a minimum of 2 bands. You've got a 2.4 gigahertz radio and a 5 gigahertz radio. And in easy mode, I manually set up 2 separate SSIDs, and I joined the download laptop, which is at the longest range out of all 4 of them, to the 2.4 gigahertz radio, which has better long-range performance. Also, that workload is going to use the most airtime, so you get the most benefit out of separating that out from the other things, which are all rate limited to some degree. And as you can see, most of those routers did at least a reasonably good job on it. That Archer C5400 did fantastic. So did the Netgear R8000. The C7, not so much. This was an interesting result because the Archer C7 has been the Wirecutter's top pick and top recommendation for a router for years now, and for pretty good reason. It's a very long-range router, and if all you're doing is single-client testing, it looks fantastic. It's near the top of the pack. It only costs like $100, so it looks like a home run. But now that we start doing the multi-client testing, you can see we're starting to put some strain on that MIPS CPU in that thing, and our latency results aren't looking so good. So that's easy mode. But the next question is, this is not how most people are going to use their routers. Most people are going to have, they're either going to have one single network name, and if you don't have band steering, that means that every single client's going to hop on the first 5 gigahertz radio no matter what. Or they'll have separate network names, but they won't really use them. They'll just join everything to the 5 gigahertz band because it's faster, and you got a ton of congestion. So next slide. Hard mode. With hard mode, there's one SSID, and all the clients either get band steered or they don't. The Archer C7 and Archer C5400 do not feature band steering, and you see all that great big scream in red right there. Your experience truly, truly sucks when you just join these 4 devices all into one band and let it rip. Your latency is absolutely awful. Like on the C7, we're seeing latency of up to 6 seconds downloading a web page. You're seeing latency of up to 1.5 seconds on a VoIP call. That's just not going to fly. The C5400 is not much better despite costing 3 times as much. The Linksys E8300 does considerably better. That is a tri-band router, and it does have band steering. Unfortunately, it's a little brain damaged. The E8300, they have a proprietary name for their band steering feature, something with smart in the name, because of course they do. And it ignores the 2.4 gigahertz radio entirely. It only steers between the 2 5 gigahertz radios, which might not sound that bad. There's a lot of environments where you don't want to use 2.4 gigahertz at all because it's too crowded. But when I was reading the documentation on it, it said that it picked whichever 5 gigahertz band was the strongest where the device was. Now, this is a little brain damaged if you stop and think about it, because your 2 5 gigahertz radios are about that far from one another in a little plastic box. And they're only a couple of 100 megahertz at most away from each other frequency-wise. So unless you've got like a really weird RF multipathing situation going on, again, everything's just going to hop on the 1 5 gigahertz band. And in fact, those results are really kinder than the EA8300 deserves. One of the workloads, I can't remember which one. I think it might have been the browsing. No, it wasn't the browsing. It was the download. I think. Yeah, with 71.8, it was the download. So one of those, I actually did get onto the second 5 gigahertz radio, but I literally disconnected and reconnected that damn laptop 50 times before it hopped over to the second 5 gigahertz radio. I did something similar with a couple of the others, but they just kept hopping onto the first radio over and over and over, and was like, okay, that's what this is. In reality, most of the time, everything's going to be on one radio, and the E8300 didn't look any better than those other two did before. Now we get down to Netgear R8000. That was that facehugger looking thing in the first picture with the radios, with the routers all together. And that actually does have band steering, and it's not stupid. So on that one, the download was on the 2.4 gigahertz, I believe. That actually might be on 1 to 5 gigahertz channels. Look at that bandwidth. I'm not sure, but it used all three of its radios and it distributed things amongst them, and you can see the results. We actually had decent results here. We did still have some serious contention in that I think the 4K stream and the browsing were on the same band. And so we had some contention, and you can see our latency isn't ideal in the browsing, but still it's a hell of a lot better than anything came before. Next. So my next thought was, okay, let's look at this mesh stuff. I was writing this article for the Wirecutter. It was really about routers, but at this point I was just kind of on a tear. I wanted to prove my point. Also, I wanted to explore all the things. So I got the my favorite of the mesh kits together, the Netgear's Orbi and Plume. And I thought that what I was going to see is Orbi not really doing all that great, because while Orbi does a great job of distributing signal all through your house, they did a wonderful thing in that they have a dedicated, very high-speed 5 gigahertz backhaul channel the client devices can't get on and cause contention problems with. Unfortunately, for whatever reason, Netgear decided that all of the Orbi devices, whether you had one satellite or two along with your router, they all deliver the same client-facing channels. So all of your devices in the house, if they can see each other, are still going to have to back off and wait for the other to finish, and you still have congestion, even though you've got these multiple access points, which is dumb. Plume, in theory, should have done much better because Plume much more aggressively utilizes spectrum. However, Plume, for one thing, is only a dual band device, not tri-band like the Orbi is. So there is no dedicated backhaul. It just kind of has to ladder step things between 5 and 2.4 gigahertz. And with the, I believe, 7 access points that I have for Plume, 7 pods, in theory, and most of the time, it will use a ton of spectrum because each pod only needs to have one channel in common with the next pod it's going to talk to. And it does try to utilize much more spectrum so you don't have so many congestion problems. Unfortunately, you have no control of it. Plume's cloud optimizer sets up your topology based on its sensing in your house. And usually the cloud optimizer does a great job of what's a computationally difficult task for a human. Unfortunately, sometimes it inexplicably does something really stupid. This was one of those times. Every single pod in my house was on the same 2.4 gigahertz and 5 gigahertz channel, so we have bad results there. It still did better on this than most of the standalone routers did in hard mode. Despite all the contention, it is still smarter, and those are really, really low latency pods, but that's still not great results. Next. So, in order to really prove my point about congestion and not having workloads on the same channel, I had to break out the ubiquities. I put 3 Ubiquiti UAP AC lights in the house and just let everything connect and do its thing. I did not tweak one single thing. Those are right out of the box connected. And as you can see, the results absolutely blow every single thing else that we tested out of the freaking water. We've got 142.7 megabits on our download. We've got our full 29.9 out of 30 megabits on the 4K stream. Our worst latency on browsing is all of 325 milliseconds. And the VoIP call, that's literally just one packet you're looking on that hit 307 milliseconds in the Amber. That's actually the very first packet. And I shouldn't say packet, I should say file. The very first file that you fetch, for whatever reason, is always a little slower than all the rest. But you see the 99% is down there at 89 milliseconds. That's literally all the way up to except the very first file that I downloaded, which was at 307 milliseconds. So this was awesome. We only had 2 of those workloads, sharing an access point and sharing a band. I think that ended up being the browsing and the VoIP call were on the same access point. But either way, as you can see, pretty much no congestion and everything just screamed. If you're not familiar with them, those are $80 access points. So 3 of those things together cost $240, which is less than most of those tri-band routers were. Next. And by next, I really mean that's pretty much it. Those are my conclusions. I'm still testing all this stuff. After that, I started chewing my way through the workload of just like every router that might possibly not suck for the wire cutter. We're still working on that. The results on that should get published really soon now, but unfortunately, a lot of those things suck so hard that the manufacturers start crying. They will send you another one with the theory that the thing tested that sucked. It must have been because that was just a bad unit. They want to send you another one. To be fair, sometimes that's true. That has actually happened.
1.3 and 2
Once. That would be, yeah, I mean, that's always a possibility. That would be a really dangerous move on their part because I would dearly love to write that up for a big publication, how I caught a manufacturer sending me a cheating unit. And, you know, most of these things I'm at least mildly familiar with from seeing them out in the wild in my, you know, local sysadmin and consulting career. So, you know, if I see an $80, you know, D-Link DIR 842 suddenly doing 200 megabits from 50 feet away, I'm like, okay, it's time to walk down to Best Buy and buy one of these and see what happens. And open them up and, you know, see what's actually inside it. And, oh, yeah, I would write that up.
Yeah, it's much more realistic to say, oh yeah, they got great tech, but lousy quality control.
That's another thing, too. So, like, right now, specifically D-Link, one of their routers was going to be our pick, the wire cutter. The wire cutter kind of bends me over a barrel because they're just bound and determined to recommend a $100 router. And, you know, $100 routers are pretty much bargain basement trash. I had one of the biggest American networking equipment vendors tell me directly. I mean, it wasn't technically on the record, but she made no bones about it. She said, yeah, we don't care about anything that costs less than $200. We'll build it, somebody will buy it, but as long as it works at all, we're done giving a crap. Because, you know, they have metrics on what sells in the brick and mortars. If somebody walks into a brick and mortar looking for a router, more than 9 out of 10 of them will walk out with something in the $200 to $250 price range. So they're like, you know, that's where our target customer starts. Yeah, we'll make the stuff that's cheaper than that, but we really don't care about it. And that dovetails with my own observations about what is or isn't decent quality in router, so it wasn't a big surprise, but Wirecutter, they've been recommending that C7, which is surprisingly good for, you know, an $80 to $100 router for quite some time, and it's gotten them a lot of clicks and makes them a lot of money, and they're scared to recommend something that costs a lot more now. But I'm like, well, you know, you also got a lot of pushback from people that weren't happy with that router, and I'm demonstrating with this modeling why. So anyway, D-Link had their flagship router from 3 or 4 years ago, the DIR 880L. It's being sold now as a budget router. Still the same thing that was a flagship at the start of the 802.11ac era, and it's perfect, man. It's cheap. It's got a good ARM CPU in it, dual core. It's got great range. It's got band steering, which is almost impossible to find in any. You'd be amazed. Most of the tri-band routers don't have band steering at all. It's crazy. So the DIR, it's got band steering. It's got great performance. It's got a great CPU. It's got VPN capability built into it, and the damn thing's selling on Amazon, you know, for like $90. Sweet. We talked to D-Link, hey, you know, these things, this is not going to get discontinued anytime soon, is it? Because, you know, it's getting a little long chain. No, we have no plans to discontinue that. Guarantee it'll be there for another year. And so we're getting ready to publish the article, and all of a sudden on Amazon, like every single vendor that's selling it is like, you know, only 10 in stock, order now, and the price has gone up $35. It's like, shit. And now we talk to them, and oh, well, yeah, stocks are running unexpectedly low on that. So now we're testing more crap and
shifting our production capacity onto the newer models that we make a higher profit on. So
well, and their successor, the DIR 878, on paper looked like it should have been great. Largely the same specs, but you know, with a couple of things upgraded, and the price is like $140. But at this point, I've been going hammer and tongs with the senior editors at Wirecutter long enough. They were prepared to say, okay, $140 is fine. We can recommend that. But, well, you know, we need to get them to ship one. Let me actually test it. And when I actually tested it, it was not good. The range was terrible compared to the 880. And it had what appeared to be a firmware bug. that would not show up in typical reviewer testing when you just slap iPerf across and call it a day. Yeah, an iPerf test from medium or short range would look fine, get 200 plus megabits. Long range wasn't as good, but that could be tolerable. I mean, we're still talking about an inexpensive router. But when I did that browsing workload, the one that actually, looks more like actually browsing web pages and does a bunch of parallel fetches, yeah, I was seeing even when I just did that unthrottled, just that by itself, no other congestion, nothing, the same location that would get about 190 megabits on the 16 meg sequential would only get 13 megabits on the browsing workload, which is not normal. Usually you'll see like 90 on that. And in the actual multi-client testing, we're seeing even with everything set up perfectly and the download segregated on a different band, yada, 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 seeing, latencies of like 2,500 milliseconds all the way down to the 75th percentile. So something was just clearly broken as hell, and it looks like a firmware bug to me, and I think they just plain didn't catch it because from what I've seen, none of the vendors are QAing their shit as thoroughly as I do when I write these things.
I was about to ask about that,
Yeah.
So if they, come out with their new flagship product and they had this one that was working so well and had great reviews and, why not upgrade the components, but continue with kind of what they had as opposed to, coming out with this brand new latest and greatest and then not testing it. And because even if there wasn't just the bug, it sounds like it performs a lot worse than an older version of what they already had. And, in technology, if you underperform your predecessor, you're not going to be there very long.
I don't, from what I've seen, most of the vendors aren't QAing their stuff worth a shit. Netgear honestly really stands out in the consumer and small business space. They are head and shoulders beyond, Linksys and D-Link and TP-Link. When I talk to them, like as a reviewer, I'm not talking to just like, marketing and sales people. Like they have engineers on the call. Mm-hmm. And, they'll talk to me about PHY and QAM encoding levels and the whole line. Like they're comfortable talking about that. Whereas most of the other vendors, hell, half the time I'm not even talking to anybody at the actual vendor. I'm talking to like their agency, and they're like, oh, well, are you using the ASUS ZenBook and how many streams on your iPerf? It's like, no. I'm not doing that. And, no, this is not an issue. I don't know how to use iPerf or, yada, yada, yada. I know what I'm doing here, folks. Yeah.
A lot of that could be, I'm sorry, none of our engineers actually speak English.
That can be a problem to some degree. I actually did talk to somebody somewhat technical in D-Link about that DIR872 because I try to be as gentle as I can with these vendors because they are sending me shit for tests that I'm not having to go buy retail. That's certainly worth something. I always feel like, if your product is gonna get completely dogged, I feel like it's the humane thing to do to let you know the results in an email before it publishes live. And I was like, hey, your 878 just did not perform like an 880. I think you got a firmware bug. And the ad agent's like, oh shit, okay, panic mode. Let me grab somebody. And I spoke to somebody last night in the house with the power out on the cell phone, which is the only power piece of electronic technology in the house. And I was trying to go over it with her. And so they're going to send me another one. They're hoping, they're confident, by which I mean they're hoping that, I got a bad device and that everything will magically be fine on the next one. Like, well, do you have any Linux experience? No, she did not. But I'm not sure to what degree the person I was talking to was a suit versus an actual engineer. She was a product manager and she was at least a little technical, like she knew what iPerf was and she could at least, talk somewhat intelligently about it. Like, she had absolutely no Linux experience. It was like, oh, well, I know some people in the company that do. So I'm not really sure if that is the state of their engineering or if, she was more of a, middle manager or what. But shit, we'll see. I gave her a link to the tools. Like, well, it's in a public repo. Here's the actual thing. Here's the configs you want. Here's how you trigger what I saw. Here's the exact distance and number of interior walls and yada, yada, yada. All these tests were run at. We'll see. The good news for me is that a lot of the time running all these tests takes a surprising amount of time. I thought it would be a lot quicker and easier than it was. The problem is For a good product, it's really quick and easy. For the shitty ones, it can be really hard to get SSH pub key off to actually go through on the long range device. So I end up just fighting and fighting and fighting with it, trying to get connected to run the tests. But for this one at least, I've got it super easy. I can literally just plug it in and forget the rest of the 4 laptops. I can just set one up and do that, net burn with the browsing workload. If I get like that much throughput, I'm like, nope, it's still broke, guys.
How much bandwidth does a SSH connection take normally?
It's not really a bandwidth issue. It's the crappier devices in the long range test, which are at the edge of the range. And I think this is an issue in SSH because the crazy thing is you can take a laptop that will actually move 40 or 50 megabits of throughput on this HTTP stuff and not show a single packet dropped, but latency will average around 40 or 50 milliseconds, frequently spike to 300, and occasionally spike up to like 1500. Like I said, you'll get 40 megabits of HTTP throughput and be like, okay, well, it's a little dodgy, but whatever, it's fine. Like nothing's hanging and I have to restart or whatever. But if you try an SSH, specifically pub key off, the damn thing will time out over and over and over again. Now, if you move your keys out of the way so that your client doesn't know that it should try a pub key at all, you'll get a password off prompt immediately, type in your password, it will immediately authenticate, and boom, you got a shell. Thing is, that's not really what you want for scheduling shit. So like I actually have filed a bug with OpenSSH, and they're arguing, and they want me to do a whole bunch of shit with TC to simulate it because they're positive that 90% of the packets must be getting dropped or something. I just haven't had time to chase that the whole way through because of course the problem is never your product.
No, of course not.
So,
So in the meantime, really, what I'm having a couple of things. I've actually ended up. So the test site where I do the download laptop, it's deliberately really too damn far away for 5 gigahertz. It's I think it's. Well, actually, let me look it up real quick. I busted out the laser tool and measured it exactly and put it in the key. 43 feet and 4 interior walls away from the router, roughly 15 degrees off of perpendicular in the walls it's having to go through, and some cabinetry. So, really in real life, I would never be trying to make that as a 5 gigahertz connection, but a lot of people will be, either because they don't know any better or because they're in a god-awful apartment complex and they're drowning in 2.4 gigahertz. So I tested anyway. And I was expecting okay, well, I'll get crappy test results on a lot of these, but I'll at least get the test results, and I want to show the actual numbers from having actually run the test. It was frustrating because, like I said, I couldn't get the damn SSH off to go through. If you could get it off, all the tests would complete just fine. But getting it off and you just trying it over and over and over and over again, and waiting through timeouts and okay, this is gonna time out in the control C and try again. And I ended up spending half an hour just trying to get the thing off to run a test, which I would need to do 3 or 4 times for the whole battery of tests. It was just killing me. And in some of the devices, I just never could. And now what I'm realizing they have to do with some of them, I've actually got I think it's a little bit too old school, potentially sexist to actually call it that way in publication. But I've privately started kind of referring to it as the pro T and the ladies T. In that bedroom, the pro T, where I was doing everything, is off in the farthest corner of that room on a desk there. There's also a desk across the room, both ways in the nearest corner, that's a good 18 feet closer. And most of the devices will connect okay there and actually run the test. And I think I'm just going to have to start complicating the results yet again with saying, okay, well, it can't do it at all out there. Here's the results, this much closer in. Be aware. Do not buy this device if you have long-range shot committing, which my experience, most people will, because it's amazing how quickly 40 feet and 4 walls rack up.
You're in a house.
Yeah.
It's all yours and everything. You should look at for the test, during the test, the power over electric and plug in
No,
to the
those things,
laptops.
but
Oh, they do, but they're going to
They
be better.
do, but like literally just for that, that's a good idea. I would never use one for actual, like I care about this.
Yeah.
But for just out of band control, that's not a bad idea at all.
Because you don't even need, you can just hard code
Yeah,
IP addresses. You don't even need like net access or anything.
yeah,
You just need to be able to connect to them so that you control quickly.
yeah,
That
that's
happens.
a great idea. I would normally never buy and use those. Well, you know, the problem with that is, no, I can't do that. Because the thing that you're forgetting is that the power over Ethernet, that's one great big antenna that you're modulating to a signal.
That's true.
And it's pretty damn easy to throw off birdies in 2.4 and 5 gigahertz from those things.
Also, they tend to burn out after about 2 weeks.
Really?
I wasted, I don't know how much money down a hole trying to do that. With Belkin and I think 2 other manufacturers, I just went through them. All right, it's just the whole idea is not workable.
Yeah, it's on my list to professionally review those things too. I actually want to lump those together with, you know, the Wi-Fi extenders, which pretty much every Wi-Fi extender on the market right now is a complete pile of ass and will do you no good at all. It may make your situation worse if you had in there at all. About 90% of the time when I see one of those in the field, removing it actually improves the situation for every single device there. It's possible to make a range extender that doesn't suck, but nobody's doing it yet.
Chops the bandwidth in half? Is that what it does?
Among other things, yeah. It doubles congestion, it chops the bandwidth in half. It's worse than chopping the bandwidth in half because what most people are doing, we've actually got a pretty good post about that up on Reddit right now with some nice graphics showing you know, your signal strength, and as your signal strength drops off, your airtime percent utilization for the same amount of bandwidth shoots up. And what most people will try to do with these things, you think, okay, well, I've got usable Wi-Fi apps. I'm like, well, it's okay out here, let's say 50 feet from the router, but I want to get out here 90 feet from the router. So I go buy a range extender and I put it out there at 50 feet where, you know, the Wi-Fi is still okay. And, you know, then I'll be able to do the thing over there. Well, the problem is, A, you're getting your maximum amount of airtime used because you've got just absolutely terrible, you know, you've got your worst encoding, you know, you've got your most retries and whatever out here, and now you're cutting that in worse than half. You're trying to start out with that, and then you're also trying to go another 40 feet out to your, you know, thing, which has an equally bad, and now they're both fighting, so it's worse than cutting it in half, which is absolute garbage. To actually get any benefit out of it, you got to move it way up further, closer to the lateral, and everything is just absolutely freaking phenomenal. And you only
Put
end
one
up,
every 10 feet till you get where you want to
yeah,
go.
you only end up expanding your usable coverage by like 10 feet. And that 10 feet that you've expanded it is just as crappy or crappier than the absolute worst that you had before. And so that doesn't do what you want it to do. Like I actually showed this on a graph with like circles and, you know, a gradient showing the signal falling off in the whole nine, and like the gradient, for the extender, a different color, and its gradient started out at the alpha level, you know, when you had the original one. And so you kind of see what's going on. And the interesting thing about that is, if it's done properly, if you're out there at like 33% of the distance out to your maximum, you know, range, which is probably about where your extender ought to be, somewhere between 33 and 66%. You don't expand your usable coverage much, but when you look at that gradient, what you can see really quickly is you actually can offer much faster coverage out of the edge of where you already had a signal than you were without. So the right way to use the extender is put it way in where you don't even think you have a problem. And it doesn't really extend your coverage much further, but it makes it suck a lot less out at the edge of what you already had. But all of that is still assuming that the extender is actually built right, and that it's got a dedicated backhaul channel, and it's extending you out on a channel that you weren't already using, and that you've got a single SSID so that you don't have to worry about what you're connecting to versus the other. Then it's what you get. Unfortunately, what all the extenders out there are doing now, 90% of them offer a different SSID. So you have to manually connect to the extender's SSID or the original SSID. And then just to add insult to injury, the damn thing's broadcast on the same band that they backhaul to. So it's just completely new. You can get absolutely no value out of this damn thing whatsoever, and you should just go throw it in the trash. off the record, one of the major vendors is about to actually make an extender that doesn't suck. They're going to make it the right way. It's going to be tri-band. It's going to have dedicated backhaul. It's going to offer, it's client facing on a different channel. It's going to use the same SSID. It's even going to freaking band steer back to your original router, and all the parts don't have to be from the same manufacturer. So they're doing it as right as it possibly can. You can even put the damn thing in access point mode and plug a device into it, or you can plug wired devices into it and use it as a bridge. Fabulous. Unfortunately, it's going to retail for about $300, but it will actually be an extender built right. The question is why you would spend $300 on an extender when you could have spent like $350 and gotten a two-piece Corby kit that would perform it.
Or spend $200 and have an electrician run Cat 6.
Well, I'm firmly with you on that, but there are just an awful lot of people in the world that absolutely will not do construction one way or the other. They just won't freaking do it. So
I tried everything to try. I've got a room over the garage that's my work area, and my wife gets the router sitting next to her, so she's got all that bandwidth and everything available for her iPad and everything. So I tried everything. I tried the Falcon, and I can't remember the other two brands of power line extenders, and I tried multiple access points. I didn't get as far as mesh, but I spent a lot of money on that. And then finally, when I called the damn electrician, I said, Cat 6 through my attic, please, run it down here. Give me a wall jack, which was easy to do because I was on the other side of the wall in the attic.
yeah,
Well, you didn't have no demo. Hose law. Boom, there you go.
yeah.
Plug it right in. And so I just ran a wire down the corner and across the room behind my wife's desk and plugged it into the back of the router. And that's absolutely the solution I should have started with, because I would have saved hundreds of dollars.
Well, it's like back in the day, my dad used to say, talking about speed tickets, you can outrun the cops, you can't outrun the Motorola, you can't outrun like a freaking Ethernet cable.
Nope.
Just not going to happen.
That's I wish I had run fiber.
Yeah. That's one of the things that makes me so mad about that marketing. Where you see, shit like up to 5.3 gigabits, on the box, like with the D-Link, fire engine red shit.
Not happening.
Well, you and I and probably everybody in this room knows perfectly well that's crap, but most of the consumers out there don't. And, in my consulting career, I have had to explain to people over and over and over again that no, their Wi-Fi isn't faster than wired. And they firmly believe that. They think that if they go wired, they'll actually be slowing down. That's why I have written so many thousands of freaking words at Ars Technica laying out all this stuff and, demos and, yada, yada, yada. Cause I'm just like, okay, I'd had enough of all this marketing bullshit. This has got to stop.
That's spread up there with trying to explain the difference between bandwidth and throughput.
But, yeah, it's been
No,
cool.
10 ships cannot cross the ocean in 1/10 the time that one ship can cross the ocean. It does not happen.
Although really that's the difference between bandwidth and latency.
Not true.
Because your throughput's still there. You can carry 10 times the amount of cargo.
Yeah, you can
You
move
can't
it,
get
but
there 10 times
it's
faster.
not, it's not moving any faster.
You want to get there 10 times faster, you got to talk to North Korea and have them build you a missile.
But you don't know where it's going to go.
China's a big place, so you can just say, yeah, it's going to China. They can hit China. Start asking for a specific location in China, you might be.
Well, Guam's kind of a small target.
They'd be better off aiming at Mongolia.
Well, or Alaska. I mean, anywhere in Alaska, you don't have to worry about what you hit in Alaska. It's all the same.
Well, I
Because
know.
long range air
But in Alaska, if you hit Alaska, who would know?
Well, there'll be that one guy
No.
that's living on that 700 square million mile.
The space guys will know. They'll get a lot.
Oh, we'll all know because either they missed Sarah Palin and she won't shut up about it, or they hit Sarah Palin and she shut up. We'll know.
Or
No doubt about
they'll
that.
hit the only Starbucks in Fairbanks and everybody will know.
No pumpkin lattes for you.
Yes, this stuff's been pretty cool. I mean, you know, up to the point that the wire cutter hired me to start testing the mesh stuff, I really just didn't give two shits about Wi-Fi because I'd had enough professional experience with it. Just be like, okay, that's the crap that, you know, you connect to with your phone and maybe your laptop if you're really slumming it. And other than that, you avoid it. That was all I really felt like I needed to know about it. I have dreams about Wi-Fi at this point. I still hate it. It still sucks, but now I know exactly why it sucks. You can do more with it than I actually thought that you could if you know what you're doing. But yeah, it's still the best way to speed up your Wi-Fi is to not use Wi-Fi because you know your worst enemy is congestion when you've got multiple devices trying to do things at the same time. So you can try to you can try to separate them into multiple collision domains by getting them on multiple radios or multiple access points. But the best thing you can do is get as many of them on a wire as possible. Like for example, if you've got access points or if you've got like a router that does wireless bridge mode, you'll get much better performance plugging 5 devices into a switch connected to that access point or router and having them all go over that one wireless link than you would if they were directly connected each with their own, because that router will aggregate all their bullshit and it won't actually congest with one another the same way that they would. So you get much better performance with a single wireless link, even though it's the same amount of devices doing the same amount of traffic than you would if they were all individually connected.
Too many people believe that the solution to inadequate Wi-Fi is more Wi-Fi.
Well, you know, if you're, the thing about it is, a lot of the people out there that are having that problem, they start out and they truly do have the world's shittiest router. I mean, I can't tell you how many times I've replaced, you know, a Time Warner or AT&T supplied edge device with a Nighthawk, and all of a sudden everybody's happy, it's good enough, and yeah, sweet, this rocks. But, you know, once you've progressed beyond that point, once you've gotten the decent router, you know, getting the $500 router ain't gonna fix it. And adding Wi-Fi extenders ain't gonna fix it. You know, now you're at the point where you really gotta architect a better solution.
It's kind of like if all of us were in a room trying to talk to each other at the same time, and the fix was to bring another person in that could talk a lot louder than everybody else.
Well, the fix is to give us all megaphones.
I had some shitty routers that had been sufficient for what I was doing, but